Hello, this video is going to explain the way you can create a snake game using Visual Studio and Windows Form applications. I'm going to show you how the game looks like very briefly. Let me hit the start button. After this quick demo, I'm going to show you the code and tell you how it's possible to create such a game. As you see, this tiny line segment that moves in this green field is my snake, and I'm trying to move it by pressing the arrow keys so that it can eat the red dots that randomly appear on the screen. As you see, the red dot is now here. I'm trying to eat this one and then head toward the next one. Of course, I have to avoid these black line segments. These are called the obstacles. And also, I cannot hit the four walls around the whole green field. After eating 10 red dots, which I call it apples, after eating 10 apples, the speed in which the snake is moving becomes faster, and also after every apple that the snake eats, the length of the body will increase. So as you see, the length of the body is now longer than what it was before. And obviously, if you play a long time, this snake becomes longer and longer. And, if you cannot manage to eat an apple without hitting the borders, like the way I did it, that's when the game ends and you have lost the game. I'm gonna first show you the way this game is implemented in C#, and then after that I'm gonna show you a completed version of what you can do to make this look much better. Okay, but this is the very naive version with no interesting graphics or anything, right? Let me end this and get into the coding a little bit. So I have all the game's logic in this class called the snake game. You'll be given this code for the homework 5, so you'll have this. And this snake game basically has a bunch of events for eating an apple, for hitting an obstacle, or hitting the snake body. These events are the critical events of the game. The first one causes the number of apples, the total number of apples that the snake has eaten to be incremented by 1. It causes the length of the snake body to grow a little bit. And also, after 10 of these events, we're gonna speed up and we're gonna go to the next level. And we're gonna speed up the speed of the snake. Hitting an obstacle or hitting the snake will cause the game to be ended. These are basically the fatal errors. The game will not continue after the snake hit itself or hit the obstacle. Then I have, so that's for each event, I have a delegate declared this way. And also, I have an enumerator that's, has left, right, up, and down. These are the 4 directions that the snake can move. The direction of the movement, the direction of the snake can be changed by the user when the user presses the up arrow, the bottom arrow, the left arrow, and the up arrow, the down arrow, the left arrow, or the right arrow. So I'll show you all the details after this. Then I have a class point for specifying a single point in the field. Then I have a line segment, which is made of 2 points, a start point and end point. Line segment is used for two purposes. One is to represent the obstacles, and the second one is because we use line segments to represent the body of the snake. Not only one line segment, but multiple. Originally, the body of the snake is made of one line segment, but as the snake moves and turns and tries to go over the whole field to eat all the apples, the line segments that are part of the body of the snake will increase. You may have, after a snake becomes very long, you may have a snake with 20 consecutive line segments, right? But the line segment is made of 2 points, the start point and the end point. And it's basically a simple class with some getters and setters for both the start and end, and a constructor that makes a line segment. The game logic is all in this class called a snake game. I assume the size of the apple is a 4x4 circle. So it's a 4 pixel by 4 pixel circle. It's a small one. If you want to increase it, you can increase this number. It's a constructor. That's the initial value of the apple size. Then I have 3 events. Eat apple is the type of eat and grow. Hit an obstacle is the type of hit wall and lose. Hit itself is the type of hit snake and lose. So these events with these identifiers or these names use these delegates as their types, right? So we have an internal event, eat apple, called eat and grow, one for eat wall and lose, one for eat snake and lose. Then I have a single point for the start location of the snake. Snake should begin a sub point. I have set this start in the demo I showed you to the middle of the field, so it starts at the very middle, right? And then I have the snake body, which is a list of line segments. I told you the body of the snake is going to be a list of line segments. The obstacles would be a list of line segments as well, because you may have at least 4 line segments, because you have to specify the borders of the field. So the border is the field is a square shape or rectangular shape field, so it needs to have at least 4 line segments for its borders. These are the minimum 4 obstacles you have, but you can have more. As you noticed when I ran the code, I had like 4 line segments sitting symmetrically on the field, and if the snake hits any of those 4, the game will end. Then I have a list of points for apples. The game that I showed you, the demo I showed you, had only 1 apple, but you can have many apples. You can have 20 apples. Then I have the current direction. That's gonna always keep track of the current direction of the snake. It's gonna either be up, down, left, or right. And then, as I said, you can change that by pressing the arrow keys when you're playing the game. Then I have a few methods. One is add apple. This method is called twice. One is when you want to begin the game in the constructor of the game. I'll show you later in the constructor of a snake. Let me actually show you right now. It's here. It's within the constructor of the game. I call add apple. And another time we call this is after 1 apple is eaten by the snake, we're gonna replace that apple, right? This is the time where I need to replace the eaten apple. This happens after I realize that I have to replace an apple because the apple is eaten, right? I'll show you the more about the detail, more about the logic of the game later, but let's go back to the same location. So add apple basically randomly generates an X and a Y. If the X and Y are appropriate, which means they're not too close to the obstacles, or they're not too close to the line segment representing the body of the snake, then we're gonna accept it. Otherwise, if the location that you randomly generate intersects with the, or hits an obstacle, or is on the body of the snake, we're not going to accept it. We're going to try again. It's a very obvious and simple method. You can check it out yourself. I don't want to go through the details, but it can create up to and it can create actually apple count number of apples placed randomly on the screen, on the field, right? Anyways, so this is basically the apple method. Then I have the snake game constructor, which adds a bunch of obstacles at the beginning. These obstacles, the first four, are basically the borders, the four borders of the rectangular shaped field. And there are four more. I just placed them in a way that you saw earlier at the beginning of this video. And then it basically calls the add apple to begin, placing apples on the field, and then that's it. That's going to be the beginning of the game. The number of apples is going to be passed to the constructor as its third parameter. The second parameter is the length, which is the initial length of the snake, and the very first one is the starting point. The last, fourth and last parameter of the snake game is the game field size, which is has a width and height. You can select whatever you want. I'll tell you later how I set that in the Form 1 class. Now we have a move method, which is super important. We have actually two move methods. We have two overloads. One is a move with only one integer. The other one is a move with an integer and a new direction. This move is going to be called whenever the user decides to turn the snake either to the left, to the right, or to the top, or to the up, or to down. We're going to change the direction to the new direction, right? Change the current direction to the new direction. Also, we have another move method, which is going to be called after every timer tick. That's how we realize that the snake always moves forward and the time goes on, right? So when the timer ticks, we're going to go forward, right? So this move doesn't change the direction, just goes forward, right? Whatever the current direction is, it goes in the same direction. The move with two parameters, as you see here, changes the current direction, and it's going to add a new line segment to the snake body. Originally, the snake body is made of one line segment. Did I show you that? I don't think so. Originally, we only have one line segment, as you see here. That's only the beginning when you start the game, because the snake doesn't have any curves in its body. But the moment the user decides to make the snake turn with a new direction, what we need to do, we need to add a new line segment to this array list of segments, and basically place another segment to the list of all segments that, to the list of, all the segments that represent the body of the snake. And this is how we do it. It's very simple. I said that the last we add the new line segments at the end, and that's pretty much all I wanted to say about this one. The next one is these if statements. If the direction is up and you try to move, if the current direction is down and you try to go up, or if the current direction is up and you try to go down, and if the direction is right and you try to go left, or if the direction is left and you try to go right, it doesn't do anything, because turning in a opposite direction is illegal. Only you can turn 90 degrees. You cannot turn 180 degrees. That's not legal. So keep that in mind when you're playing the game. You know, when if it moves to the right, the left arrow key is not responsive. It doesn't do anything, which should be the case, right? And then it calls, after all of these, it calls the move with one parameter. The move with one parameter, as you see here, it gets the number of steps that it has to move. The number of steps basically show the speed of the snake. After every 12 milliseconds, the 12 is a number that I have specified in the code. After every 12 milliseconds, we are going to generate a new frame for the animation of the game. And after, you know, in each update, after every 12 milliseconds, we gotta move the snake body a step pixels forward. So if the step is equal to a small number, the body of the snake moves very slowly. If you increase the step, if you double the value of the step, the snake moves faster. If you quadruple it, it moves 4 times faster. So the step is linearly proportional to the speed of the snake body, right? And it's very simple. It basically checks the current direction. If the current direction is left, it moves the last line segment's X value toward the left by a step pixels. If it's right, it's going to move the X value toward the right by a step pixels. If it's up, it moves the Y value step pixels to the top. And if it's the direction is down, then it moves the Y value of the last point of the snake body a step pixels toward the down direction. And after it does this movement, it checks whether we want to grow or not. The grow will happen only if the snake hits a apple. In that case, what we're going to do is we're going to grow the body of the snake. The body of a snake grows by not letting the beginning pixel of the snake body move. Otherwise, if you don't want to grow the body of the snake, you don't run this line. This line allows us to move the body of a snake forward. But if you want to grow the body of the snake, you don't run this line. And that basically makes the body of the snake grow. Let me briefly show you in a very small annotation. So let's say this is the snake body, this is the head, and this is the tail. This code basically specifies this. It says, if you want to grow the length of the snake, because the snake has eaten an apple, move the head forward, but don't move the tail. Let the tail be here. That's where I return, right? If you don't want to move the, if you don't want to grow the length of the snake, you basically run this code. This code basically moves the tail in the same direction as head moves, and basically the snake doesn't get longer because the snake now ends at here, it begins at here. So I'm sorry, it ends at here, begins at here. So the length will remain the same L, right? But if you don't run this code, then the length will grow a little bit. How much with the step value? So yeah, it was a little bit hard for me to explain all the details, but that's pretty much it. I have an if and an else part. The if is for the y direction, the else is for the x direction. So, but both of these will be executed if you don't want to grow. If you want to grow, we just return immediately. That's it. So that's the method. That's basically the logic of the game. Now, within this move, I skipped some parts. Within this move, I skipped some parts. What part did I skip? I skipped the part where I realize the snake has hit the obstacle. That's where it happens, right? And in this case, I just trigger this event. The event is called hit wall and lose. Also, I check whether a snake hit its own body. If that happens, I trigger another event, hit a snake and lose. And if I realize in this for loop, if I realize that I have eaten an apple, after I set my will grow boolean to true, I will do basically trigger this event, eat and grow, right? So these events that I have defined allows me to have low coupling or loose coupling between the class snake game and form one, right? Basically, these three events that I have defined, one of them is eat and grow, will decouple and separate the snake game logic with the snake game UI, which is in form one. So now snake game can be copied and pasted in a different project where you can have your own, let's say, UI, right? But the UI I've created for it is this in this form. It's basically it's called it's a Windows form application. It's a Windows form, and it's called form one. Let me show you the code of form one. What I'm going to show you is the constructor, which basically creates 2-3 event handlers for the 3 events that I have. I kept the event handler for eat and grow empty. You need to basically make it full by making a noise after the snake eats an apple. And maybe a few more changes, which I'm going to explain later. The other one is hit a snake and lose. That's an event handler for hit a snake and lose events within the snake game. Here I have a stop the timer, and that's it, right? But you need to add like a little bit more. You need to show a game over on the field, and you need to say, you have eaten, let's say 20 apples, game over, right? And then I have another one for hit wall and lose. Similar, I mean, you can use the same logic that you use here in this one, because hitting the wall and hitting the snake body will both result in lose. The only difference is I have mentioned in the assignment, for this one and this one, you need to make 2 separate noises. So other than that, these 2 events should be handled in a similar fashion. Anyways, so also I have a new bitmap for the image inside the field, and I have created a snake game. I have set the original location of the snake on the middle of the field, -20. I have set the length equal to 40. So the reason I put -20 here, because the length is 40. So when you look at the final product, you'll see the snake is right at the middle. The reason is 40 divided by 2 is 20. That's why I did this. Number of apples is right now 1, but I can change it to any value I want. Let's set this into maybe 10 and then run it again. As you see now, I have way more, right? You can just set these to crazy numbers as well. I mean, it's not a big deal. I can set this to maybe 2000. When I run it, something crazy happens. Yeah, 2000. And as you walk, on this field, you eat apples, and the game runs seamlessly. There's no special lags in it. Everything is completely smooth because the logic is written in a nice way. There's no crazy loops, as you see, the length of the snake grows as I go forward. So I'm gonna skip that part. Yeah, I mean, you can play with it. Let me stop this and tell you what needs to be done, other than the ones that I showed you. There's a main timer tick event handler, because I have a main timer in this original form, and this event handler basically constructs the next frame of the animation for the game. It calls the move with the step, and it invalidates the field. When you invalidate the field paint is going to be executed, because that's the event handler for the paint event, right? Invalidate causes the field to be repainted, and the repainting causes the paint event causes the field paint event handler. And basically in this one, I have done the following. I have created for loops to draw all the apples, and also I have drawn all the obstacles, and I have drawn the whole body of the snake, right? Maybe I could have skipped some parts because some part may not change their location, like the apples may not change their location after every update, so I may not. I mean, I could have basically skipped this for loop, but I just redraw everything every 12 milliseconds, because it's not going to be very time consuming. There's a key down event handler. This is going to basically react to the button or key, I should say, not button, the key down events that are triggered by the user when the user presses the up arrow, the down arrow, the left arrow, the right arrow. And I will have said, let's have a switch case. If he's up, then move to the up direction, down, move to the down direction, left, move to the left direction, and right, move to the right direction. And that's pretty much it. That's the whole game, right? What you need to do to make things better is specified in this document. Let me show you. That's part of your homework 5. Basically, I have listed them here. The number of apples is set to 1, as I showed you originally, but the user should be able to change it to any positive number. So make it happen in a nice way. I'm going to show you a demo of one of my previous students who did complete this homework in a nice way, and I'll tell you how it's possible to let the user select any positive number for the number of apples. This is the crazy 2000 apple scenario with super long snake, as you see. Then I have the second item, which says when the game is lost, either the snake collides with itself or the obstacle, the application must show a message declaring the number of eaten apples. You can declare the message right in the middle. You can basically draw a text. I have explained before how to draw a text on a form, on a picture box, or you have seen it before, how to draw text. All you need to do is for this event handler and this event handler, you can just draw a text and say game over, you have eaten, let's say, a number of apples, right? And you can basically use the graphics from image, field image as your graphics, and then you can say simply, let me just show you here really quick. G dot draw a string, and then you can just pass your string, the font, the brush, everything. So it's not a big deal, you can do that. Don't open a dialogue and say, or a message box and say game over. That doesn't look good, right? Make it look nicer. And that's one thing you need to do. The next thing is, when any of the three events eat and grow, hit wall and lose, and hit the snake and lose are triggered, the event must be handled by the main by playing a sound. To play a sound, you can use System.media sound player. Just download any sound that is free on the internet and just make it happen. It's not a big deal. And then it says after every 10 eaten apples, the speed of the snake should increase. Make that happen. I told you how to increase the snake's speed. Basically, the step that you pass to the move shows how many pixels it goes forward. Right now, let me show you the step. Right now, the step is 1, right? If this, instead of 1, if I had 4 and I run this, as you see, it just flies, right? And the game becomes much harder. And still, I will have, I said, honestly, I have no problem playing the game. I lost the game. Anyways, so I think you can play better than me. Let me move forward with the rest of it. Just make sure that you always increase the speed after every 10 eaten apples. And what you need to do is keep in mind that the maximum is 10. Don't go beyond 10. 10 is a crazy number. No one can play with a speed greater than 10. And then use a progress bar in the main form. You already used progress bar before for the previous homeworks, but use a progress bar to show the current value of a step with a number between 1 to 10. And then, 1 is the minimum, 10 is the maximum. Just make that happen. Make the red dots representing the apples blink. To blink that, you just need to modify the code in the field paint, and maybe do a periodic function that's make the apples blink. I'm going to show you a completed game so you can see how it looks like. And then it says clicking anywhere on the game should pause or resume the game. That's not the big deal. You can just pause the timer itself. You can stop the timer and resume the timer. The timer is the main driver of the game, because the timer tick event causes the field to be repainted. So if you pause the game, if you want to pause the game, you have to make the timer tick method not to be called, or it must become disabled, right? And then it says you need to provide a convenient way for a user to customize the field by adding extra obstacles. That's a 20 extra point. If you do that, you're going to get 20 extra point. And in order to do that, you can let the user choose from 10 predefined patterns of placing multiple obstacles on the game. And that's how you get the extra credits. That's pretty much it. Submission is similar. Just put the source files, put the video, and read me the text. Listing everything that you could do and you couldn't do. Before I end this meeting or this video, I should briefly show you an example of one of my students' games in the previous semesters. So I can select how many snakes I want, how many apples I want. Let's pick 30. and then I press this. That's the entry form. That's the form that I haven't implemented in the starter code that you will receive. You can add yourself. And then I will press the play button, and that's going to begin the game. As you see, it's much nicer than what I showed you. I'm not sure if you hear the sound, but after I eat an apple, there's a apple eating sound will be played. And more importantly, as you see, the number of apples appear and disappears on the form, and I can eat as many apples as I want. I should be aware not to hit the obstacles and the body of the snake. And then at the bottom you see this progress bar. This progress bar is very nice, but you don't need to use this type of progress bar. You can just use a predefined progress bar that you use. You see this progress bar, as I say, now I'm in the it's going forward, after some points. This progress bar is going to go forward all the way to the hard, where I have the number of steps is the amount of steps is set to equal to 10. Right? After I hit my 20, after I eat my 20th apple, now you see the speed has grown. Now this student has done a great job of converting the apples to from dots to the real apple images, and also it has created some rotten apples. As you see, if I hit the rotten apple, I will lose. That's an extra thing my student did just to create a nicer game. Anyways, at the end, when the game is over, you just print this message, and you have eaten this many apples, and that's it. So that's pretty much it. Thank you, and hope you can create your own game and make it look really nice.